morning friends, and in this video we are going to discuss about the vector quantities and the three-dimensional geometry. So first of all, you might have studied that different type of physical quantities are there. Some are called as the vector quantities and some are called as the scalar quantities. Now first of all, what is a quantity? A quantity, a physical quantity is same thing, and a physical quantity or quantity has been defined mathematically like or anything which can be measured is called as quantity. Now when we measure, then we find things around us like the distance, displacement, temperature, we measure areas, we measure volume, and we measure velocities, speed, acceleration, etc. Some of them are the scalar quantities and some of them are vector quantities. So just I like to go directly into the idea of the vector quantities. So vector quantities. Now vector quantities are the quantities which has direction as well as magnitude. Like if you say that direction part is the very important part, because magnitude part you know that. Magnitude are someone simple example is time and mass, which are scalar in nature, they are scalar quantities. And the mass is just like, suppose you have 5 kg of mass and then you break this down into the 3 pieces of the 2 kg, 1 kg and 2 kg respectively. So this is how the physical quantity, if you multiply a bag of 5 kg by 5, it means you have the 5 such 5 kg bags, etc. So this is a simple operation, but the operations on the vector quantities are different. First of all, how they are represented. So if you just pay attention to a line, then this is called a directed line. This is called a directed line. Directed line. Why this is called directed line? Because it has two sense of direction, one along this and one along this. That's why this is called as directed line. Now I want to restrict this definition. I don't want it to have two dimensions because it's a line. I want to become, because what is this actually? It's a line. I want to make it a directed line. Right? Directed line means line which has one direction. It means I remove this direction. Now this is my directed line. It has only one sense of direction, that is along this. In this sense of direction it goes. Now if I cut the two, take the 2 point like this and remove all this, this will become a directed line segment and the sense of direction will be very much, and this is called as a vector quantity and it's notated as AB bar. So the sense of direction of AB bar, BA bar is just opposite of that. So BA bar is from B to A and the AB bar is from A to B. So AB bar is just negation of BA bar. And the magnitude part, the length of this line segment is called as the magnitude. So length is represented as AB and this BA. Both are same, both are same length, because the distance between A and B is same as the distance between B and B, because they are straight lines. So their magnitude are same but the direction is different, and this quantity can be called as vector quantity. Now if I use the idea of the three-dimensional geometry, and then so if I break this thing as linear dimension, like the one dimension. So this you just saw that this can be in this direction, this can be in this direction, this can be in this direction. But if I say that the two dimension means it has only two direction. Two dimension is generally represented as a Cartesian system of representation like this. So in the two-dimension geometry, you know, you might have studied the coordinate geometry. If you take this point as origin, so every point here is represented by two things. One is called the ordinate, other is called as abscissa. If you take a point P here, P, having the coordinate x, y, then you see that starting from O to P, this is a vector quantity. So OP is a vector quantity. OP bar is a vector quantity. Now this vector quantity, if you pay attention to this, then I drop a perpendicular from here. This part is called as X from here to here, OA, and this part is called as Y. So AP is Y. Now if this one is making an angle theta, then this part will be called as XR cos theta, because the length of this one, I say that the mod of OP is R. So this is R. So OP bar is R and P is the position vector of the point. So OP is, now if you say that if this line, this vector OP makes theta degree with the positive direction of x-axis, then the cosine of that is cos theta is x upon r. Okay, and this cosine is called as direction ratio cosines. Cosine cos theta is called direction cosines, and this theta is the line which this vector or the line which makes with the positive direction of x is called as the directed angles. Now if you see, this is y-axis, so this angle is called as beta. So it means the line or the vector AP, because it's a line segment, you should not call it the this one. If I want to make it a line, then I have to make it like this. Like this goes like this. This also goes like this. I have restricted it only between O and P, so making it a line segment. And this line segment OP is making angle theta with the positive direction of x-axis, which is on the right hand side in this direction, and the positive direction of the y is above, like that. So this right now is not required. So in this case, you see that the theta is the angle, or should I call it just alpha. So alpha is the angle that the line makes with the positive direction of x-axis. So the cos alpha is x upon r. Similarly, if I just try to understand what is y part, so I just drop a perpendicular here. So this line is B, so I have to find this one. So we'll find cos beta is equal to, what is cos beta? Cos beta is adjacent with this part, that is y. So y upon r. So we have x equals r cos alpha and y equals r cos beta. Now if you see this direction OP, what is OP? The modulus of OP is under root x square plus y square, and this quantity we call it as r. So if you write r square equal to x square plus y square, so again if I just use this one, that x square plus y square is r square, and add them up, so we find r square cos square alpha plus r square cos square beta equals r square. Now take r square common, so r square, then you find cos square alpha plus cos square beta equal to r square. These two cancel, and then we find cos square alpha plus cos square beta is 1. So if we just assume that the point P, which is right now in this two-dimensional plane, if it is in a space, then this point x now will be given with 3 coordinates x, y and z, and then we have our x-axis, y-axis all becoming very much weird and different. It looks like this is my y, this is x, y-axis, and this is z-axis, and the point here will be given by the coordinate x, y, z. If I join like this OP, then I find now here r, so r square now becomes x square plus y square plus z square. And suppose if this line OP makes angle alpha with the positive direction of x-axis, beta here and the gamma here, then this relation will become cos square alpha plus cos square beta plus cos square gamma is 1, and this is called the direction cosines. So cos alpha, cos beta, cos gamma are direction cosines, and the alpha, beta, gamma are the direction angles. Now I go and resolve these components into the vector form. So first I would like to discuss about the triangle law of vector addition. Triangle law, this is simple, starting from the very beginning. Triangle law. What is triangle law? That if you have a vector, then you know that a vector is notated by points like this, A, B, bar, and A is called the initial point. A is called the starting point or the initial point, and B is called the final point or the terminating point. So it is just like starting from A to B. So if you have a vector AB bar like this, and then you have another bracket vector BC bar which goes in this direction, then its resultant will be AC bar. Means suppose it's just like this, if you gone from A to B, so A to B, plus then you move from B to C, means finally where did you move? To C. And where did you start from? So you start from A, so this becomes AC bar. This is called the triangle law of addition. Simple. First it's just like you have a starting point A, then you go from here, like suppose if I say P outside A, then you go to B, so this is AB bar. From there you go to C, this is BC bar. Now if I join this, then what is this? This is AB bar plus BC bar. So this is AB bar plus BC bar. Again if I go from here to here, and that is D, so this will become CD bar. So now if I join this, then what will become? AB bar plus BC bar plus CD bar. So this line segment AD bar will become AB bar plus BC bar plus CD bar. Now if I have a vector AB bar going in this direction, suppose if I reverse the direction and make it go like this, same magnitude, whatever this length between AB, same length here, but only direction is reversed. So this vector AB bar, now here this is called as minus AB bar. So what is this? Minus AB bar. Now suppose if I start from A and then I gone to this minus B, and then one point starting from A gone to C, and then if I join like this, then what you get? From A to B, that is minus AB bar, plus B to C, plus B to C, that is BC bar, is nothing but A to C, AC bar. Now I see just like going from A to B and then B to C, it means going from A to C. So A to B, and this is, I am writing is negative B because B is actually here. So that's why it looks like this. You can write it, make it as a D also, but here we are saying that this vector, whatever is named, is just negative of this. So this is how you can find the vector sum of the two vector quantities using triangle law. Now there is also another sum that is called as parallelogram law. It says that suppose if I have a vector quantities AB bar and another vector quantity starting from same A, but it goes like this, AC bar, C. So how to find the resultant of these two? Suppose if there is a force acting at point A in this direction, I call it as F1, and another force acting in this direction, calling it as F2. What will be the resultant? Parallelogram law says that just to make a parallelogram, so it means from C draw a line parallel to AB. So this will become like this, and then from B draw a line parallel to AC, just like this. So this becomes a parallelogram. So since in the parallelograms we know the opposite sides are equals and parallel, so this is F1, so this is also F1. I can name it as D. And if this is F2 and this is also F2. Suppose if the angle between these two vectors is theta, then the theta is the angle between V1 and V2. Now here geometrically I produce like this. From there I drop a perpendicular from D onto the extended line of AB. So like this. This I name it as M. So if I join, if I try to find the resultant, so resultant of this vector will be along the diagonal of this. So suppose since I have been talking as these vectors as F1, F2 means I am taking them as the forces. So the resultant of the F1 and F2 I can take it as F, that is the single force. So now if the angle between this F1 and F2 is theta, it means this angle is also theta. Now if you use this trigonometry, then you find that here this BM bar is F2 cos theta because it is adjacent part, and this DM bar is F2 sin theta because this is perpendicular part. Now in triangle DAM, this is a right angle triangle, so the Pythagoras theorem can be applied, which says that AD square equals AD square as AM square plus DM square. Okay, I am writing big so that you can understand it. So the font size I have increased so that readability is increased. Now AM is what? What is AM? That is F1, because from here to here this is F1, and then this F2 cos theta. So it is F1 plus F2 cos theta whole square plus what is DM? That is F2 sin theta. F2 sin theta whole square. And this AD I am writing it as F square. So now this is F1 square plus F2 square cos square theta plus 2 F1 F2 cos theta plus F2 sin theta square, F2 square also. So now if I combine this F2 cos square theta and F2 sin square theta, just taking F2 square common, so sin square theta plus cos, which is sin square theta, it looks like sin theta square. So sin square theta and cos square theta, they add up will become 1. So our resultant is F1 square plus 2F1 F2 cos theta plus F2 square, and this is F square. So what is F? Just remove this F square from here, put this in square root. This is the idea of the resultant. Now if this is the resultant, then what is the angle of the resultant vector with some of the known vectors like the F1? This is alpha. How can you find this? So again use the idea of trigonometry. Tan alpha is opposite, which is F2 sin theta upon adjacent, which is F1 plus F2 cos theta. So F1 plus F2 cos theta, and this one gives you the angle alpha, which will help you to find out the location of the resultant vector AD in the sense of the given known vector AB. And this is how this parallelogram law works. So I think in this video we stop it here only. In the next video we'll talk about the other operations on the vector quantities.